Welcome back again, class. Thank you for joining me. So today we're going to continue our conversation on simplifying rational expressions. Now, yesterday we covered basic simplification and multiplication. So today that leads very nicely into our conversation of division. Now, for division, the big thing you need to remember is you need to multiply by the reciprocal, or basically flip the second fraction. So notice what's happening here. Notice I'm changing my division to multiplication. And how am I doing that? Notice I'm switching that second fraction on itself. All right? So, and I know you've heard this numerous times, but now we're going to apply it to rational expressions. So again, you change it to a multiplication problem by flipping that second fraction. And then everything from there is exactly what we did yesterday. So let's take a look. Now I'm going to erase that so it's not messy to look at. So once you have it flipped, again, now it's just going to be the same. Now factor cancel. So x squared minus x minus 20. Well, that is going to become x minus 5, x plus 4. You can't really do anything with x plus 6, so we're just going to leave that. Times x minus 3, can't really do anything with that either. And then you can pull a 2 out of that 2x plus 8, and you'll get that. All right, and let's take a look at what cancels. So the x plus 4's cancel out. So my final answer, my simplified version, there's an x minus 5 on top, x minus 3 on top, a 2, and x plus 6 on the bottom. All right, now, while everything is the same, there is one little itty bitty complication that I need you to be aware of. All right, so stating the restrictions, stating the excluded values. All right, so excluded values, you can easily see that x plus 6, that x plus 4. Now, what I want you to realize, that second fraction has been flipped, right? So because it was originally a division problem, that second fraction actually got flipped in order to turn it into a multiplication problem. So when the problem started, that x minus 3 was in the denominator. Look right there. So the little trick to this, again, the big idea is still the same, but the little caveat to this one, the trick to this, is the fact that in that second fraction, both pieces have been in the denominator, so both pieces end up being excluded values. All right? And so that gives me excluded values of negative 6, negative 4, and 3. Notice I ignored something at the denominator. I ignored that 2. Well, because can a number ever be equal to 0? That wouldn't make sense. So if you just factor out a number, again, it really doesn't matter, okay? You can just leave it. All you have to worry about are the variable expressions when you're going through this work. All right, so let's take a look at another example. So it wants us to write the quotient in simplified form and state any restrictions. So again, the first thing I'm going to do is I'm going to rewrite this. I'm going to change it to a multiplication problem by flipping that second fraction. Now I'm going to worry about my factoring process. So 2x squared plus 7x plus 3. So this is one of our slightly more complicated ones to factor because we have a 2x and an x. But again, that's why we spent so much time reviewing factoring to help you through this. All right, and again, you can always check that 2x and 3 will give you 6x. The one that x will give you 1x. Those will add to the 7x that you need. 2x plus 1 doesn't factor, so we just leave it. Same thing with the x plus 5. It doesn't factor, so we can leave it. Then the bottom here is another one of those difference of squares. X plus 3, x minus 3. All right. And now I'm going to cancel anything that is the same on the top and the bottom. And when I do that, all I'm left with is an x plus 5 and an x minus 3. And now, when we're stating the restrictions, remember we take every piece from the original denominators. Oops. Sorry about that. But remember, in that second fraction, because it's been flipped, both the top and the bottom have been in a denominator. So both have to be listed in those restrictions. So here, if 2x can't be negative 1, that means x can't be negative 1/2, x can't be negative 3, x can't be 3, and x can't be negative 5. So sometimes you get quite a list for your restrictions. But again, the big idea is make sure you use the entire denominator, even if it was canceled. And that second fraction, you have to use both pieces. All right, last example for the day. So first, I'm just going to rewrite it. I'm going to write it as a multiplication problem by flipping that second fraction. All right, now I'm going to factor. Now, that x squared plus 2x, that always seems to get students, okay? You guys always forget how to factor something like that. If the x is in both terms, you can pull the x out of both of those terms, just like that. Don't forget, if your x is in both of them, just pull that x out. X squared minus 3x minus 10. That is going to be x minus 5, x plus 2. X plus 3 can't factor, and x can't factor. So let's take a look here. The x's cancel out, x plus 2's cancel out. So what am I left with? Well, I'm left with x plus 3 and x minus 5. For our restrictions, again, we go back to every piece of the denominator. And in the second one, we use both top and bottom. Again, because it's been flipped, don't forget both have been in the denominator. So we get that x can't be 5, x can't be negative 2. This one already states x can't be 0, and x can't be negative 3. All right. And there we have it. All right, so this was actually really quick notes. So please make sure you write all of this down. Again, I don't think you'll find it tricky, but you do need to have all of these notes written. So please make sure you do that for me. Come back to class prepared to do your practice work.